Okay, this is algebraic reasoning review for 1.3 and 1 through 3, 1.1 and 1 through 3, 1.3. The instructions for 1 through 6 say for each problem, determine if it's linear, exponential, this is not writing, linear, exponential, or neither. Then, if it's linear, exponential, write a rule to model the data. Okay? So they want you to figure out basically what it is, and then write a rule for it. So we're going to start off just by subtracting to see if so it's like 7 minus 3, well, that's 4. 11 minus 7 is 4. 15 minus 11 is 4. 19 minus 15, that's also 4. So every last one of these we are adding 4. Okay? Therefore, this is a linear equation, which is y equals, man, this pen stinks. This is y equals mx plus b. Okay, so a real quick review of that real fast. Your m is your slope, which remember is your change in y divided by your change in x. And your b value is your x of 0, that's your start. So in this case, my x's are changing by 1. So plus 1, plus 1, plus 1, plus 1, all the way down. So 4 divided by 1 is 4. So we can say y equals 4x, because that's my slope. And your starting point is where x is 0. All right? So y is 3 when x is 0, so plus 3. That's your linear. Okay. The next one, if we try seeing if it's linear, if I subtract that, that's plus 0.2. This is plus 0.4. This is plus 0.8. You find out real quick that that's not working. So let's try dividing instead. So negative 0.4 divided by 0.2 is 2, so it's multiplied by 2. 0.8 divided by 0.4 is also 2, so it's a multiplied by 2. 1.6 divided by 0.8 is also 2. And oh look, 3.2 divided by 1.6 is 2 as well. So this one is exponential. Alright? Where your equation for that is y equals ab to the power of x, where a is your starting point and b is your common ratio. Okay? So, my y's are consistent, my x's are also consistent, all of these are going up by 1. Alright, and my starting point is at 0.2, because that's where x is 0. So y equals 0.2, that's my starting point, times 2 to the power of x. Alright. Last one. So let's just start off by dividing these real quick. So if I go 10.3, clear, 10.3 divided by 11.7, we get like 0.88 dot 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 forever. And if I do 8.9 divided by 10.3, I get 0.86. And if you did it one more time, 5.3 divided by 8.9, you get 0.59. Alright, so this is clearly not exponential. Alright, so we'll try subtracting 10.3 minus 11.7, that's negative 1.4. 8.9 minus 10.3, that's also negative 1.4. Okay, so we're on a roll here. 5.3 minus 8.9. Actually, I don't know what that one. 5.3 is negative 3.6. Actually, 8.9 minus 10.3 is 1.4. All right, so this last one, 3.7 minus 5.3 is negative 1.6. So, yeah, these two might be the same, but the rest of them don't fit. So this is actually neither. N-E-I-T-H-E-R. This is neither linear or exponential, which is a perfectly legitimate answer. All right, let's try. I'm going to pause and move to the next three. Okay, this next one. Okay, so let's try. This one actually looks exponential just because you're going up by 3, then you're going up by 10, then you're going up by like 30 or something like that. So it's not linear, we can tell you that right now. So let's try dividing. 4.5 divided by 1.5 is 3. 13.5 divided by, good night, divided by 4.5 is also 3. 40.5 divided by 3.5, that's 3. And that is, when you put it in your calculator, is also 3. 121.5 divided by 40.5 is 3. Alright, so we have our common ratio. This is exponential. So we got to fill in y equals ab to the power of x. We just don't have our starting point. So in order to back up 1, instead of multiplying by 3 to go down, we're going to divide by 3 to go up, which 1.5 divided by 0.3 is 0.5. So y, or I'll say f of x, you can say y, you can say f of x, equals 0.5 times 3 to the power of x. That's your rule. All right. Number 5. This one, yeah, I'm going to go ahead and say it's linear because if I subtract 3, I get to 25. If I subtract 3, I get to 22. Minus 3 is 19. Minus 3 is 16. I mean, if you didn't figure it out, you can do 25 minus 28 and you'll get negative 3. 22 minus 25, you'll get negative 3 all the way down. All right, but you'll also notice these are changing by 2's. All right, so your slope, remember, is the change in y divided by the change in x. So that's negative 3 divided by 2. And that fraction doesn't reduce, so your slope is negative 3 halves. The other thing you're missing is the starting point. Well, nice thing about these going up by 2's is I can go down by 2 and get to 0. So instead of subtracting, I'll add 3 and get 31. So y equals negative 3 halves x plus 31. Okay. Last one, number 6. All right, these are constant. Plus 1, plus 1, plus 1, plus 1. That's nice. These ones, oh, they're not linear because you notice how this one goes down by 8 by 12. That's down by 12. But then that one goes up by 24. So that's such a big difference. It cannot be linear. So let's try exponential. Come on. Negative 8 divided by 4 is actually negative 2. So times negative 2. 16 divided by negative 8 is also negative 2, so times negative 2. 32 divided by 16 is also negative 2. And 64 by 32 is also negative 2. Now here, watch out. You might think that this is an exponential with a b value of negative 2. And if you backed up and divided by negative 2, you'll get a 0 point at negative 2. Which you're right, this would be the common ratio. And this would be your starting point. However, exponentials never have b values less than 0. B has to be greater than or equal to 0 at all times. So this is actually neither. Okay, because b will never be negative. Cannot be done. All right? There you go.